In this video, you will learn from the scratch everything you need to do to recover two files, resident and non-resident files within NTFS Master File Table. Also, you are going to understand the difference between attributes and you are going to create your own digital image. Let's start. The first thing we should do is to create our image that we need to work on. I have a USB. I have formatted to NTFS file system. What you can see here, it's NTFS file system. What I'm going to do right now is to copy 2 to 3 files into this USB. These are 2 pictures. This is the first one, and this is the second one. Now let's load another file to it. This is another file called shopping list, Cyber Edge, my channel name, and YouTube. I'm going to create the image today using FTK Imager. You can click File, create a disk image. I'm not going to create a physical disk, I'm going to create just the partition. You select the logical drive and then click Next. Now you select the partition that you need to create an image from it. I'm going to select partition E and hit finish. Now the destination, I'm going to use raw image. Okay, raw image, keep it raw for simplicity. Hit next. Case, let's name it Master File Table. Okay, Master File Table. Destination folder, I'll select where I need to save it. In desktop, C Master File Table. Okay, Master File Table. The name of the file, I will name it Master File Table Sci-Dish, my channel name, and hit finish. This will create for us the image of this partition. Once the image is created, FTK Imager will provide us with the hash values MD5 and SHA-1 and so on. Okay, close, close. Now let's add the image of the USB or the partition of that USB that we just created. Click File, Add Evidence Item, Image File, Master File Table, and here is the start of this image. Okay, you can create by your own. Okay, you can create by your own. Double click on it. This image is just loaded to our FTK Imager, and straight away we notice this partition or this image is a partition that has NTFS file system, My focus in today's video is to discuss and explain the file attributes within Master File Table. We can explain this in another video, but however, I'm going straight away to the Master File Table. To get access to the Master File Table, you can go, you'll find it somewhere here, but to make life easy, you just go to the root, and here is the files that create NTFS file system. As we said, our focus on the Master File Table. Remember, Master File Table can be anywhere in the disk. In Master File Table, all files and folders are stored as a record, and each record has 2 sectors, 1024 bytes each. And each of these records contain file and folders information. And each record, we refer to it as attribute. And also because we are going to discuss today resident and non-resident data, file and folders can be stored in Master File Table as a resident or non-resident data. If the file is larger than around 512, This we call, it will be stored outside the master file table. This we call non-resident data. And if the file is smaller than 512, that means this is a resident data, and you will find the information within the master file table. Let's try and dig into a master file table information. Within the master file table, there is many attributes, and we call them attributes ID, like attributes ID 10, 20, 30, 40, and each one of them have its own purpose. Let's try to find the shopping list. Okay, let's try to find the shopping list. If you right click and click find, we're going to search for the file name called shopping list as a text. Just type shopping and that's it. Yeah, here is it. The shopping list file we are looking for. As we said, each record will have two sectors. That means it will start from here. Always the attribute or the master file table will start by file 0. Okay, will start by file 0 and will end in two sector. It will end here. Okay, these are the two sector. A length, if you highlight them, here is it 1024. This is the size of this file 0. As we said, we are in the shopping list.txt, and I'm going to explain each attribute within this master file table. First, attribute ID number 10, referred to as a standard information. It starts by hex value 10. Okay, this is the standard information. It starts from here, and the length of this attribute is this one, 6066. Little Indian, if you convert it to decimal values, it will come to us as 96. That means it starts from here till 96. Let me try to find 96 till here. This is the length, it's 96. This is the area of the standard information. Within the standard information, we said it's from here to 96. Okay, to 96. This section is related to the time when the file is created, when the file last modified, when the file last accessed, and so on. The first, I think, 8 bytes, it will show us when the file was created. And here is it. It's the 8th of March 2024 at 12:40, which is the time right now. Okay, which the time, before 15 minutes when we start copying or creating the file to the USB. This is the last time the file was modified. And what you can see here, the creation time was after this day, which you will say to me, it's wrong. It's not wrong, because we copied this file from one location to another location, and NTFS will create the record based on the day you copied the file, and this when you create the file, okay? But however, the rest of the information will still the same when you have last modified the file. Last access day, you will find last access day. Here is it. It's today because after we create the file, we opened the file together. And when the record was updated. Then the next attribute, which is after this attribute, we said this one, 96. If we go 96, attribute number 30, which file name, the short or long file name. The size of this attribute is 128. If we go 128, up here, okay, up here. And what you can see, you'll see many information, like when this name has been created, when the last time you renamed the file, and so on and so on. All of this information is here, okay, is here. But what we are interested on, this is the end of it, and this is from where the name of the file is starting. As this being created by Unicode, that's why you find 5300, 6800, and there is ... because it's Unicode rather than ASCII when this file was created in the system, okay? shopping list. Here is the name. It's the name of it. It's shopping list. And this is the end of name attribute. Next one is 40 rather than 40. And this represent the objective ID, the volume, version in Windows, and ownership, and so on, so on. So, okay, I'm not going to spend time on it. I'm going to jump to the next one. Okay, to the next one. However, the length of this attribute is 40. 40. That means if we go 40 from 40 to 40, that means we start here. And this is the start of data attribute. Okay, this is what I'm interested on for today's session. 80, that means it's data attribute. And if we see here, if we can see here, if this is 00, that means the data is resident within the master file table. Also, we can find the size of attribute, which is this one. That means 72. That means start from here and you go 72 up to here. Okay, there is what we can see here. There is another data attribute start after this. Yes, in master file table in NTFS file system, yes, you expect to find maybe more than one data attribute, but we will discuss later. For the 80, this is the first one, as we said, and the data will start from here, okay? And the data will start from here. This is the data location. There's more information. We cannot discuss everything because of the time, run very fast, but this is where you expect to see the data, because as we said, it's a resident data because it's 00, and here's the data. Okay, what you can see is fish, egg, broccoli, carrot, and tomatoes. To export this data, you need to highlight the data. Okay, to highlight the data up here, and then right click, save selection, and type the name of the file you need to export it. Let's say we need to name it scitej1.txt. File type, it's not allow us to select the file type. And let's remember there is nothing on this folder. There's nothing. Okay, there is nothing. Let's export it and see. And here is the text document. Okay, let's double click on it and see if it will open. Yeah, here is it: fish, egg, broccoli, carrot, and tomato. And you will say to me, okay, why? How the operating system or whoever it is, how they know there is each of these words in new line? I will say to you, yes, you're right. If you go to the hexa values, okay, the hexa values, this is the fish. Okay, this is the fish. And if you convert 0D or 0A, you from ASCII, you go to the ASCII table and so on, you will find this is instruct the operating system that this is a new line. Okay, this is a new line, one of them. I forget which one of it, 0D or 0A, one of them. Okay, that means now you should understand that we have just managed to recover a text file from the master file table. That means if you have just master file table, you may be able to recover some data that is stored within master file table, especially if the data is smaller than 512. Okay. Now, what you can see, there is another section. Okay, another section. Let me find from where. Yeah, this section, data section. Okay, and within this data section, there is a name. This one is a key logger. Okay, key logger. Write in the comments below why keylogger.exe is in the same location of the shopping list.txt. Why? Write in the comment below if you know that. Okay, if you know that. Next, let's try to recover one of the pictures. Okay, to recover one of the pictures. Let's take the small picture rather than the big picture. The small picture is subscribe. Yes, if you haven't subscribed, make sure you subscribe to support this channel. Let's try to find this picture within the master file table, okay? Because it's big size, it's 23 kilobyte. I'm sure it's non-resident data. That means it will refer us to another cluster where this picture is saved. And we may be able to recover the whole picture or just part of it. Let's try. Okay, let's try. The name of it, it's YouTube. I will start from the beginning again. Right click, find. Where is find? Find. Yeah, find. And then type YouTube and hit enter. There's nothing. Let's try again. Find. Okay. Yeah, make sure you click all of this. Okay. YouTube. Why? Is the spelling is wrong or YouTube? Yes, it should be. It should be there. Okay, it should be there. Let's go again. I am in the master file table. YouTube. Find. Yeah, here is it. I don't know why in the beginning it doesn't come, but however, here is it, the YouTube. Now we are inside the metadata of the YouTube GPG file, the picture. Okay, and the first thing, as the previous one, yeah, the file 0. This will indicate this master file table record identifier. Okay, and you can get many information from here, but I'm not going to consider them right now. This is the standard attribute where we can find information when this picture was created, when it's modified, and so on. Okay, it should be the same, yeah, the same time that shopping list was created, because we copied them both in the same time. Okay, at the same time. But let's try to find this information. Maybe there is something different. Yes, exactly the same, because I have downloaded from the internet. Okay, I have downloaded from the internet. There's no interesting information for us right now. As we said, we are interested on resident and non-resident data. I will go straight away to 80 attribute or data attribute. Okay, or data attribute. How I can get there? From 10 attribute, I know the size is 96. I will go 96. And 30 attribute, the size of it is 112. I will go 112. Yeah, 112. Remember, the 30 is the short and long name attribute, and here is the name. We managed to find the name. Okay, we managed to find the name. The 40 attribute, I'm not consider this one at the moment, which is for the volume and so on. It's 40. If I go 40, and yes, we managed to get the data attribute. Okay, the data attribute, it's here. Now we are in the data attribute. Okay, 80. To know the size of this attribute, you just highlight this one, and it's just 72. Okay, just 72. That means from here, 72 till here, just from here to here. There is 2 data attribute right now in this. Yes, this we know the size now. We can know if the data is resident or not. It's 01. That means it's not resident data. 00, like the previous example, that means resident data, and we will find the data somewhere here. Okay, but here it's straight away it said to us it's non-resident data. That means the picture is saved somewhere else within this disk. Okay, how to find that? As we said, it's non-resident. That means it's outside of master file table, because the size of it is greater than greater than 512 bytes. To find out the location where this picture is stored within our image, you can go to this space and this will show us the first run list, where the first run list is located. It's in the 64. That means from 80 we go 64 till here, and this will show us our first run list. The first byte of the run list is a flag itself. It tells us the total number of bytes in run list, which here 2 plus 1 is 3. These are the 3, 1, 2, 3. Where 1, that means 06, this will tell us the size of the fragment, which is 6 clusters. Okay, 6 clusters. That means we expect this file is stored within 6 clusters. Also 2, that means these 2 bytes, this indicate for us the starting cluster where this data is stored. Now, I just created this document to represent how you can find the linting cluster and the starting cluster and so on. So the linting cluster is 06. That means if we convert to decimal, it's just 6 clusters. Okay, 6 clusters. And if we convert the starting cluster from ASCII to decimal in Little Endian, it will be converted to 4,488 cluster. Okay, 488 clusters. Now we need to find the file. Where is it exactly? Then, we need to know the cluster size of this disk. You can go to master boot record or volume boot record and so on. You will find the information somewhere. Okay, somewhere. But however, to speed up, here is it. The cluster size is 4,096. Cluster size is 4,000. Cluster size is 4,096. Then the location of this file will be 4,096 times the 488. Okay, 488. This will be in bytes. This will be in bytes. Let's have the calculator. $4,096 times 4488. This will equal to this big number, 18 million, I think, 382,848 in bytes. Then let's go and try to find the picture. To find the file, you go and copy this number, copy, and go and try to find it. Go to offset. Okay, go to offset. And here is it. Copy and paste. And yes, here is it. We are now inside the file. Why I'm sure this is a picture? Because yes, it starts by this signature, and this will show me this picture. Okay, and EXIF picture and EXIF information, and all of this information is here. This indicate for us it's a picture. Okay, now we know where we are exactly. Okay, now we know we are in the picture. Now let's try to recover the picture outside. Okay, from here we know the length of this picture is 6 clusters. That means equal 6 times cluster size 4,096. This will equal to, let's do it, 6 times 4,096 is equal to 24,580. 24,580. This is the size. Okay, this is the size. Now let's try to recover it. What you can do is right click, set selection length, and the size in byte. This one. Okay, here is it. You are now selecting the whole 6 clusters. Let's now recover it from the NTFS file system. Right click, save selection. Let's name it dig 2.gpg. Okay, let's try it like this. Remember, there is nothing right now. Let's go to out. There is nothing. Let's save it. Okay, let's click save. If you go back, here is it. The size of it, 25 kilobyte. Let's try to open it. Hopefully it will work. Okay, hopefully it will work. Double click. Here's it. Okay, if you reach here, make sure you subscribe. Make sure to write a comment. I think I asked you questions within the last couple of minutes. Make sure to answer that question. Also, there's another picture larger than this, the 25 kilobyte. Try to recover your own picture. Try to do exactly what I have done and recover it. Okay, this is how you will understand NTFS file system and the master file table and so on. I try to cover some part of NTFS file system, but however, because the time is very limited, I cannot cover everything. Hopefully you enjoyed this video and see you next time. Thank you.